at their curriculum, JAMB moves a step ahead. So sometimes you might graduate from reading PNOKK and Nyakoha, all those SSC textbook, to Nekon and Packer. Just a little bit, or Harry Day, just a little bit advanced. And that is where you have an edge ahead of other students in JAMB. Now, there are things you believe that is true based on your normal O-level understanding, but in essence, it's not correct. It's not correct. I normally ask these questions to students, and I found out that even some of the students will not know the answer. Now, 200 naira for anybody that will get this one correct. 200. You know, last time it's 500. This one is 200. The next one will be 100. The next one will be 50. It will be coming down. Now, what type of mosquito causes malaria? Any other answer? Any other answer? What type of mosquito causes malaria? Any other answer? Now, what's the answer? Are you giving me any other answer? Yes, what's the answer? Infected female Anopheles mosquito. That's correct. You see, reading a step higher than your modern biology, because your modern biology will tell you that it is the female Anopheles mosquito. But if you read a step higher, maybe a year one textbook in biology will tell you that it is infected female Anopheles mosquito. And in JAMB, the first answer you see in A is a female Anopheles mosquito. You just take it and keep moving. That one is very simple, but you failed it. That's what I'm saying. If you move a step higher, most of the answers in your O level that might be correct, if care is not taken, it will be wrong in a JAMB exam. A step higher. That's my advice for you. So for any textbook, chemistry textbook, look for, more especially a year one handout in chemistry. It's a step higher. For your physics, the same thing. Maths, the same thing. A step higher, so that you can get the mastery that will help you to get 3 something in JAMB. Or else you see end up in 2 something. Maybe 200, 220, 230. Please. You see how quiet you people are now. But that's a fact. I'm not trying to put fear in you, but I'm just trying to let you know. Do you understand? You need to move a step higher. Please. So after a class, you go home, you study, make research, open your Google it, go through it. You must learn something the teacher did not say in the class. There must be something there, a step higher. And those a step higher, they are the questions they ask in JAMB. There is no question in JAMB that you are using calculator to solve. There is no, even in mathematics. Every question in JAMB, you don't need calculator. I'm telling you the plain truth. You don't need calculator. So once you are pressing your calculator, 1 minute, 2 minutes, you are beating time. You are beating time. Okay, electric field. Now, fields are area surrounding a charged body. You're talking about electric field. There are areas around a charged body where electric force is exerted. Fields are areas surrounding a charged body where electric fields are exerted. You know, the last time we talked about lines of forces. Is that also? We have the lines of force around the positive charge, negative charge, two equal charges, and opposite charges. So those lines of forces represents the fields. There are areas around a charged body where the electric force is exerted. You might be asking, just as I said last time, why will somebody be electrocuted? Don't you know this is electricity? These are lines. It's only a stupid person that will see an electric line and you put your hand there. So why are people electrocuted? The reason why people are electrocuted is because you found yourself in the field. Once you step into the field, you have to feel the force. So even if you don't want to go to the wire will attract you. That's what we are saying. Even if you don't want to talk, once you come into the field, now that's where the force is exerted, around the field. So you might see the wire outside, actually, but you don't know where the field, the length of the field. And once you come into the field, you are automatically electrocuted. That's what we are saying. It's around them. Now, the man that studied about the magnitude of the force is called Coulombs. And he proposed the Coulombs law of force. Now, the Coulombs law states that the force of attraction or repulsion. Coulombs law states that the force of attraction or repulsion between two charges in a space, the force of attraction or repulsion between two charges in a space separated by a distance r. Let's use r to represent the distance. Separated by a distance r is directly proportional to the product of the charges. Is directly proportional to the product of the charges and inversely proportional to the square of the separation apart. Coulomb's law of forces says that the force of attraction or repulsion between two charges in a space separated by a distance r is directly proportional to the product of the charges and inversely proportional to the square of their separation apart. Now, if you have two charges, point charges, separated by a distance r, this is Q1, this is Q2. Now the Coulomb's force, which is the electric force, is directly proportional to the product of the charges and inversely proportional to the square of their separation apart. This is the mathematical representation of the law. Product means multiplication. What is the product of 2 and 4? 2 times 4, 8. That is product. There is another form of saying multiplication. Now, if we remove the sign of variation, we have to add an equality sign and a constant K. Yes. Now, you know, variation, most times in JAM question, mostly in physics, they ask you question mostly on variations. Variations. If A is directly proportional to B, now it means that if A is increasing, B is also increasing. Now, at equal amount. So if A increases by 2, B will increase by 2. That is direct variation. Now, if it is inversely proportional, A is inversely proportional to B. It means that if A is increasing, B is decreasing. Now, if B is increasing, A is decreasing. They are inversely proportional at the same rate. So if A increases by 2 under inverse variation, B will decrease by 2. Please let it come into your mind. It doesn't matter whether it is alphabet, maybe in resistance. They will ask you question in resistance. And they will now ask you what resistance will they add, whether it is in parallel or in series, to make the current this. We'll get to that one. Maybe in the next class when we treat current electricity. You understand all these things. Now, K is a constant of proportionality which is equal to 1 over 4 pi epsilon 0. That's a Greek word. It is called epsilon 0. 1 over 4 pi epsilon 0. So if I substitute the value of K in this equation, I'll have that the force is equal to 1 over 4 pi epsilon 0 Q1 Q2 over R square. Now the problem we normally have when we are marking WAEC, we found out that the students, the value of this in calculation should be up here, not down. The value of K. Because in WAEC, they don't give you the value of K. They will tell you that 1 over 4 pi epsilon 0 is equal to 9.0 times 10 raised to the power 9. That's what you see in Y. But in calculation, we found out that the students, instead of bringing it up here, they will now write Q1 over Q2 over 9.0 times 10 raised to the power 9. It is the value. This is all this value. It's not only this. So it should be up. Now, the unit of care, if I cross multiply here, I have force times R square is equal to care Q1 Q2 by cross multiplication. Now we are looking for care. Now if I make care the subject of formula, I have that care will be Fe R square over Q1 Q2. Now from here we get the unit of care. The unit of force is Newton. The unit of distance is meter square. And the unit of charge is per coulomb square because it's 2. Coulomb times coulomb is 2 and it's over, so it's per. So this is the unit of the force constant. We have Newton per meter square per coulomb square. So K is equal to 9.0 times 10 raised to the power 9 Newton per meter square per coulomb square. That's the unit of care. Now, what's the unit of permittivity of a free space? The absolute zero. Can somebody help us here? The absolute zero represents permittivity of a free space. What's the value? Is a constant. Somebody should say something. What's the unit of the permittivity of a free space? This represents permittivity of a free space and is a constant. What is the value? Even man go with textbook, you didn't see it there. Now this is a class. A class should go with a lot of communication. The students will say something. The teacher will reply. What's the value? What's the value? Say something now. Okay, if you don't know it, I don't know it. 8 points. Why do you approximate it? It's 8.85. Please don't use 8.9 next time. Oh? Okay, 8.85 times 10 raised to the power minus 12. Is she correct? Now, what's the unit? The unit of permittivity of a free space. Okay, Newton per meter square per coulomb square. All right. Now we have electric field intensity. Now you should know that electric force is a vector quantity. And it is both an attractive and a repulsive force. Please note that. Electric force is both an attractive and a repulsive force. Magnetic force is both an attractive and a repulsive force. But gravitational force is only an attractive force. Gravitational force is only an attractive force. Now, nuclear force, which one it is? You know about nuclear force before. Okay, is it an attractive or a repulsive or both of them? Nuclear force. Eh? I'm not hearing what you're saying. You are saying as if you are in dream. Okay, nuclear force is what? Is a repulsive force. Okay. Well, you try it now. I love people. But nuclear force is an attractive force. The nuclear force is an attractive force. Do you understand? It's not a repulsive force. It's an attractive force. I know your physics teacher will not tell you this one. The nuclear force is, in your school they will tell you we have 3 types of contact for non-contact forces. Is that also? They will tell you it's electric force, magnetic force, gravitational force. Nuclear force. Nuclear force is a non-contact force. That's why I'm telling you, you have to read one step ahead. One step ahead of your SSC physics textbook. Nuclear force is a non-contact force. And it is an attractive force. Just as the gravitational force is an attractive force, the nuclear force is an attractive force. But it is not in your SSC physics textbook. Put it down in your notebook so that you will not forget it. Now, the electric field intensity is defined as the ratio of electric force to charge. Is the ratio. Electric field intensity is the ratio. Is the ratio of electric force to charge. So mathematically, electric field, electric force over charge. And the unit of electric force is Newton, the unit of charge is coulombs. So the unit of electric field is Newton per coulomb. Newton per coulomb. That's the unit of electric field. Electric field intensity. That is the strength of the electric field. The strength of the electric field. Remember when we are listing the properties of lines of force, we say that the number of lines of force passing a given area is equal to what? The magnitude of the electric field intensity. The number of lines of force passing through a given area. So we check the strength of an electric field based on the number of lines of force passing through that area. So the strength of an electric field is determined by the number of lines of force passing through that area. If we present this mathematically, we have this force divided by charge. We have this K Q1 Q2 over R square times 1 over Q. If you change times, you invert. That's primary 2 mathematics. Do you understand? If you didn't go to a very good primary school, maybe the primary school didn't have Apple breaking, you na carry since you talk to time. I'm accusing some certain things. Do you understand? But in arithmetic, if you change division, what will you do? You invert. Is that also? Yeah. So Q will cancel 1. Now we have the formula for electric field intensity. We have this KQ over R square. That is the electric field around a point charge. The electric field intensity around a point charge. The electric field intensity around a point charge. Okay, kid. Yeah, my first time you forget about. Now the third one is electric potential. Electric potential is defined as the work done. Electric potential is defined as the work done in bringing a positive charge from infinity the total work done in bringing a positive charge from infinity to a point in the electric field. The work done in bringing a positive charge from infinity to a point inside the electric field. Now, mathematically, the electric potential is equal to electric field times distance. Now, dot means scalar multiplication. Why we normally use dot is to tell you that electric potential is a scalar quantity. Electric potential is a scalar quantity. electric force and electric field are vector quantities, but electric potential is a scalar quantity. So if you want to do multiplication, it should be a scalar multiplication. That is not full stop. The dot is at the middle. E dot R. And for those of you that are doing further mathematics, you should know there is a difference between this and this. Is that also? There's a difference between this. What do we call this? Eh? This is not arithmetic mathematics. I say further mathematics, my sister. What do you call this? Eh? Yeah. This is vector multiplication. This is scalar multiplication. Eh? This multiplication is not 2 times 4. It's not 2 times 4. It's a vector multiplication. But we are not in vectors, so let's not go there. So, now if we fix the value of the electric field, V will have Q over R squared times R. Now this R will cancel 1. We have that V will be KQ over R. Electric potential, electric field, electric force. The formulas are very, very important. You have to memorize the formulas. Now we'll solve one question from WAEC some times ago. I will set it on the board and we'll solve the questions for perfect understanding. You are sleeping. Man, all go to be today. That's that boy. On our 12 on happen. I'll go to an aban in our 419. You are in a class in our Lola. Please take this question. Now you write 2 similar but opposite charges. 2 similar but opposite charges minus Q and plus Q. 2 similar but opposite charges minus Q and plus Q, each of magnitude 5.0 times 10 raised to power minus 8 coulombs. 2 similar but opposite charges minus Q and plus Q, each of magnitude 5.0 times 10 raised to power minus 8 coulombs, are separated by a distance 8.0 centimeter in vacuum. are separated by a distance 8.0 centimeter in vacuum. As shown in the diagram below. As shown in the diagram below. I calculate the magnitude of the force of attraction between the forces. Calculate the magnitude of the force of attraction between the forces. 2. Calculate the magnitude of the resultant electric field at point P. Calculate the magnitude of the resultant electric field at point P. Calculate the magnitude of the resultant electric field at point P. Number 3. Calculate also the electric potential at point P. Calculate also the electric potential at point P. P. Now the diagram that's the diagram, and the question says take care as 9.0 times 10 raised to the power 9 Newton per meter square per coulomb square. Now this is a typical wire question. In the question, calculators are allowed. Even WAEC these days used to give calculator. So as you come into the hall, they will give you calculator so that you will not say the reason why I failed mathematics is because I'm not with any calculator. But some will be so careless that at the end of the day, they will go home without any calculator, while some will still go home with about 10 calculators. Now, what's the value of the charges? The charges is what? 5.0 minus 8 coulombs. Now the first question is calculate the magnitude of the electric force. Now the electric force is K Q1 Q2 over R squared. K is a constant of proportionality and is giving us 9.0 times 10 raised to the power minus 9. Now, another thing you should learn is how to use your calculator. How to use your calculator. You know, if you are good in calculator, you can find out that the OBJ. Yeah? You will not even write anything. You will just be using your calculator and solve the question. Because this calculator is a mini computer. Once you give the calculator instruction, it will give you an answer. You can solve a full question in a calculator and press equal to. It will give you an answer. If you know how to press calculator. If some of you here cannot even press a standard form, 9.0 times 10 raised to the power 9 in a calculator now. Now let's substitute. K is 9.0. K 9.0 times 10 raised to the power 9. Q1 5.0 times 10 raised to the power minus 8. Q2 5.0 times 10 raised to the power minus 8 over R is 8 centimeter. You have to convert to meters. You have 0.08 squared. Because to convert to meters, you have to divide by 100. To convert to meters, you have to divide by 100. All right, so those with calculator, can you help us out? Multiply this, what do you have? Those, yeah? Did I know you? Okay. What do you have? I'm looking at you now. You are afraid to say what is in your. You are not the one solving. It's a calculator solving now. No, it's not the total. The first one. 9.0 times 10 raised to the power 9 times 5.0 times 10 raised to the power minus 8 times 5.0 times 10 raised to the power minus 8. Two point what? Minus 5. Is that minus 5? Minus 8 minus 8 is minus 16. And 9 minus 16 should not give us minus 5. Is what? Times 10 raised to the power what? Okay, 2.25. All right. Now 0.08 squared is what? 6.4 times 10 raised to the power minus 2. Minus 3. Now divide. Put it in standard form. You say 0 point what? 0.0035. Now somebody should put this in standard form for us. 3.5 times 10 raised to the power minus 3 Newton. .5 times 10 raised to the power minus 3 Newton. Do you have any question? Check your own calculator. Okay. Please, your decimal point, make sure it is in 2 decimal place. Eh? Do you understand what I say? What did I say now? Okay. Make sure. So that answer should be 3.52. Because 5 is up to 1. You add it to the other one, it will give you 2. Is your mind there? Now, the electric field, this is where the calculation comes from. The resultant electric field would be E is equal to E1 plus E2. The resultant electric field at point P. What is the resultant electric field at point P? So point P, for the negative charge, the distance to point P is 5 centimeters. For the positive charge, the distance to point P is 3 centimeters. Now remember, in this calculation, signs are important. Remember, in the force, we didn't put the sign. We believe a force can either be an attractive force or a repulsive force. But from the question, you see it's an attractive force, because unlike charges, attracts. Is that also? But in the electric field, you have to put the negative sign. This one, the first one is negative, and the second one is positive. So in calculating this, you have a negative answer. In calculating this, you have a positive answer. Then you add them together. Whatever you obtain is the answer. Or else you make mistake. Or else you make mistake. Okay. Now, one of our sisters said, how do we get K? K is a constant. It's a constant of proportionality. In the exam, they will still give you the value of K. Yeah? If you have K, please look up. Yeah, now you want kind of medicine, or just because never a lesson center. 1 over 4 pi epsilon 0. You multiply 1 over 4 times pi is 22 over 7 times 8.85 times 10 raised to the power minus 12. This is the value, the epsilon 0. If you multiply this and find the inverse, you have this. Do you understand? It's above your scope, but we need to sometimes to move a step higher. Do you understand? So you move a step higher. That's how that constant 9.0 times 10 raised to the power 9 is obtained. All right. Now E1 is K Q1 over R squared. K Q1 over R squared. So E1 9.0 times 10 raised to the power 9. Now the charge now, the negative sign times 10 raised to the power minus 8 divided by 0.05 squared. Divided by 0.05 squared. The centimeter you divide by 100 to obtain the value. So can somebody help us out? 9.0 times 10 raised to power 9 times 5.0 times 10 raised to power minus 8 is what? Minus divided by 0.05 squared is what? Ten raised to power minus. Now divide, what do you have? Minus 450 divided by 2.5 times 10 raised to power minus 3. Minus minus 1.8 times 10 raised to power what do you have? Minus 0.18. Okay, minus 0.18 is what's the value in standard form? Okay, minus 0.18 Newton per coulomb. Do you have any other answer apart from this? Do you have any other answer apart from this? Go and get a calculator. If you don't have a calculator, tell your parents to buy one for you. Eh? Or else you sell your phone and get a calculator. Sell your phone. Sell your phone. If you are a serious student, that phone is a distraction. Yeah, it's a very big distraction. Sell the phone. Bring your phone. Go at 30,000, 40,000. Or you go take a very nice calculator and you have still money here about Christmas. We say what? 1.8 times 10 raised to power 4. Okay. Minus 1.8 times 10 raised to power 4 Newton per coulomb. All right. Raise, please. Can I have a calculator there? $450 divided by 2.5 exponential minus 3 is equal to 180,000. So 1.8 times 10 raised to power 4. 1, 2, 3, 4, 5. 1.8 times 10 raised to power 5. The reason why you say it's 10 raised to power 4, you just counted the number of zeros. It's not the number of zeros, it is the movement of the decimal point. Do you understand? The movement of the decimal point. 180,000. You move the decimal point. 1, 2, 3, 4, 5. The movement of the decimal point. If you count the number of zeros, you say it's 4. You have failed it. But it is the movement of the decimal point that will tell you exactly the how many you have counted. So if you start moving 1, 2, 3, 4, 5, that is 1.8 times 10 raised to power 5. Now, for E2, remember its negative sign. E2 will have K Q2 over R squared. K Q2 over R squared. So when we fix, substituting 9.0 times 10 raised to the power 9 times 5.0 times 10 raised to the power minus 8 divided by 0.03 squared. Somebody asked us a question. He said, what is the dimension of K? Dimension of K. I ask this question to my year 1 students always in physics 102. What is dimension of K? Just so that they will feel it. When they will feel it, they will bring money. So now, you will be opportune to know the dimension of K. So that by the time you go to UNN, you won't feel it in physics 115. All right, please. Open up. 9.0 times 10 raised to the power 9. What do you have? We still have this value again. This is 450 now. Divided by 0.03 squared is what? Times 10 raised to the power minus 4. Now divide, what do you have? 5.0 times 10 raised to the power Newton Coulomb. So, the electric field, resultant electric field, E, will be E1 plus E2. That's how to calculate the resultant. The resultant of two vectors is a single vector that can represent two or more vectors in magnitude and direction. That's the resultant. Is a single vector which can represent two or more vectors in magnitude and direction. So once the language calculate the resultant comes in your mind, two things should be in your mind. One is the magnitude. Two is the direction. Now, in this question, the question just says, calculate the magnitude of the resultant electric field. Is that also? It just ends there. Now, it doesn't go with only the calculation. Calculation only gives you the magnitude. Now, what is the direction? Because whenever you hear the word vector, a vector is identified based on the magnitude and the direction. So once you hear vector, you know that this quantity goes with magnitude and direction. So if you want to calculate the resultant electric field, that means you check the magnitude and also the direction. I wish God will give you a wonderful mind so that you understand all these things. These things are easy. But because you will be fast in the hall, your mind will not be there. So once you calculate the magnitude, you keep moving. You will not determine the direction. So that's why I wanted to define that resultant for you. So we now add up E1 is minus 1.8 times 10 raised to the power 5 plus E2 is 5.0 times 10 raised to the power 5. Please add up what you have. 3.2 times 10 raised to the power 5 Newton per coulomb. Now, what is the direction? What's the direction from here? Are you going to just reason now critically as a science student? What's the direction of the electric field? Is it towards the negative or towards the positive? Eh? So the electric field is towards the positive. It is more towards the positive charge. That means the electric field is more towards the positive charge. That's why the answer is positive. 3.2 times 10 raised to power 5 Newton per coulomb. Now, in our year one in university, this sort analysis you used to do in our chemistry in WAEC. You know, in those days, I don't know the teacher assigned when I was school. Those, do you understand? Now, in our year one in university, they gave us sort analysis. Now, in the sort analysis, they will tell you that A is this, B is this. They won't give you the name of the salt. And they will ask you to analyze. And all the reagents will be there. All the reagents. You start to test this one, test this one. At the end of the day, you will tell them that salt A is this, salt B is this. And after the whole salt analysis, you cannot identify the salt. You have failed the whole thing. And then, I'm secondary school better. Now, boys, our chemistry teacher got that one. So we just did the salt analysis, made observation, inference. After everything, we didn't state the salt. We submit the book. Thank God it's not an exam, it's just a practical exercise. But the result of that, you have 0 over that. You know, in your year one, you work in groups now. All the people see university secondary school, they will be working together. All the people see federal, they will work that's year one, first semester year one. But as time goes on, you start forming another group. And then they say Igbo, and then can't go like this. And they call this, I join on like this. Group and they like wine too much, I join like this. They will, and that's how they will separate in the rooms. You know, when you come initially, you have roommates. You stay with your roommates. But as time goes on, by the second semester year one, they will start to have migration. People will start to migrate. Maybe your roommate is a chain smoker and you don't like smoking. You get another room. You get a room where you can another chain smoker or so how Anozie, they will be smoking morning, afternoon, night. Then the people that read will stay in one room. They will read from morning till night. Now the cultists will also stay in one room. Those ones will be coming back by 4 o'clock a.m. every morning. Now that's how you separate yourself. Now we have those that are gamblers. That room is a room of gambling. 24 hours they are there. They will not go to school from first day to the last day. Some of them can even miss exam. Gambling. They will use their school fees and play gambling. I'm just trying to tell you what you will see. Because I believe by this time next year, all of you will be in university. So when you will start seeing it, you will say that Dr. Osike told you this kind of thing. And when some of you got just saying na year one by final year, you bought wakago niche. So God forbid what? Okay, let's solve for the electric potential. The electric potential at point P will be V1 plus V2. Calculate the electric potential around the first charge. Calculate the electric potential around the second charge. You now add them together. But now, in electric potential, we don't determine the direction. That's why the question did not ask you to calculate the resultant electric potential. Just ask you to calculate the electric potential. Because electric potential is a scalar quantity. Do you understand? From questions, you understand. Electric potential is a scalar quantity. That's why they didn't ask you to calculate the resultant electric potential. You just calculate the electric potential. So V1 is K Q1 over R. (9.0 times 10 raised to power 9 times 5.0 times 10 raised to power minus 8. Remember the sign is there. Divided by 0.05. What do you have? What do you have? Minus 9,000. What's the unit of electric potential? Volts. Anything called potential, the unit is volts. Whether it is gravitational potential, the unit is volts. Electric potential, the unit is volts. Potential difference, the unit is volts. Minus 9,000 volts. Now V2 is what? We have 9.0 times 10 raised to power 9 times 5.0 times 10 raised to power minus 8 divided by 0.03. What do you have? 15,000 volts. So the total electric potential V is V1 plus V2 minus 9,000 plus 15,000. What do you have? 6,000 volts. That's the electric potential. Most questions involving electric field is always easy, bearing in mind the formulas and the relationship. Apart from the formulas, the relationship. Now, any calculation involving larger numbers raised to power minus 12, raised to power 9 is not seen in JAMB. Because in JAMB, your calculators are just simple adding machine. But they will ask you more concerning the relationship. Now, electric field is electric force divided by charge. That means invariably, electric force is electric field times charge. That is what they will ask you. That simple relationship. Do you understand? Electric potential is equal to electric field times distance. Electric potential is equal to electric field times distance. We also use that formula to solve question in a capacitor. We also use that formula to solve questions in a capacitor. Let's solve one more question. Now, two parallel plates are charged to a voltage of 40 volts. Two parallel plates are charged to a voltage of 40 volts. If they are separated by a distance of 500 centimeters, if they are separated by a distance of 500 centimeters, calculate the electric field intensity between them. Calculate the electric field intensity between them. If they are separated by a distance of 500 centimeters, calculate the electric field intensity between them. Can somebody solve? Who is solving? Who is helping us out? The question, we have the electric potential, we have the distance. The question, calculate the electric field intensity. What do you have? 8 volts per meter. 8 volts per meter. Can we represent electric field as volts per meter? Is it possible? 8 volts per meter. We are talking about the unit now. We know the answer is 8. Eh? He said, because we found out that the unit of electric field is Newton per coulomb. Is that also? Check your notebook now. The unit is what? Newtons per coulomb. But he said that the unit here is volts per meter. Is that correct? Eh? The class in Castle. Are they correct? What you can tell? All right. We have V is E times D. And the V is what? 40 volts. D is 500 centimeter. If you convert to meters, what do you have? 5 meters. So if you substitute in the formula, we have that the electric field is V divided by D. This is 40 divided by 5. The electric field is 8 volts per meter. Please, another unit for electric field is volts per meter. He's correct. So electric field can be represented as Newton per coulomb or volts per meter. Please write it down. Write it down. Electric field. The unit of electric field can be represented in Newton per coulomb or volts per meter. Newtons per coulomb or volts per meter. Now we have a question, and the student says, what is the dimension of the force constant K? And the unit is Newton per meter square per coulomb square. What is the dimension? Dimension is your first term SS1 work in physics. Dimensional analysis. In dimension, we use the first letter of the fundamental quantities. Please, it's better you listen. This question can come from anywhere. Just like I told you in your year 1 exam, if you have a wicked lecturer like me, he can say ask you that in exam. Dimension. The dimension of mass is M time T length L. Electric current. Electric current is what? E. Electric current is a fundamental quantity. Is that also? And the unit of electric current is what? The unit is what? Amperes. Temperature is there. We just pick the ones we are going to use now. All right. Somebody said the question, let's just answer that question. He said, is it a must you must convert from centimeter to meter in all cases? In all cases or equations? Okay, you know, equations, you are talking about mathematics. Yeah. Is it a must? Now, the only place you are not requested to convert from centimeter to meters is only in linear expansivity. Is only in what? In linear expansivity, 1 centimeter is equal to 1 meter, and 1 Kelvin is the same thing as saying 1 degree Celsius. Now, apart from linear expansivity, anywhere you solve calculation using centimeter, It's only in linear expansivity. Apart from linear expansivity, the SI unit of length is meters. It's only in linear expansivity because it's a fractional increment. So the conversion is infinitesimal. Please. Okay, back to what we are saying. K is equal to Newton meter square. Now, please, is why you listen. This is the unit of force. Is that also? Yes. This is the unit of length. Is that also? This is the unit of quantity of charge. Is that also? And quantity of charge is current times time. Is that also? And force is mass times acceleration. Is that also? So you have to convert every one to the SI units, the fundamental quantities, if actually you want to get the dimension. Because dimension is talking about the first letter of the fundamental quantities. So if we convert Newton is MA, mass times acceleration. Meter square is in the normal position. Then this will give us IT raised to power minus 2. So let's pick their dimensions. Dimension of mass is M. Length, acceleration is LT raised to power minus 2. This is L raised to power 2. And this is I and T raised to power minus 2. So we have this MLT minus 2, L2, I minus 2T minus 2. So with this, you equate the variables. So K, we have only one M, L raised to power minus 2. Minus 2 minus 2 is what? Minus 4, I raised to power minus 2. That's the dimension. Dimension is talking about the first letter of the fundamental quantity. If you don't want to use I to represent current, you can use E to represent electric current. Or you can use C. You can use any alphabet, but make sure you tell us that this alphabet represents electric current. Without having much question, let's move into what? L is 2. Sorry. It's time. I say by 12:30, so I will end around 2:30. It's 2 hours now. Mwana kuzi ya de be tired. Ngwana ne de tired. What kind of student are you? Yeah? If you about visual game, kitting on email and wire from 12 to 9 in the night before going home. How long can you spend if you about visual game? You don't about gambling. Visual game, you must include about visual. I don't know. You go there to spend your money. Current electricity. You called me. Which one you don't hear what I said? In a way, a problem. Current electricity. Do you have a heavy man? It is very large. Now we are done from static electricity. Now current electricity. Current electricity is talking about electricity that is mobile. Electricity that is mobile, that have the capacity to move from one place to another. You know that electric current is the rate of flow of charge round a circuit. Rate of flow. When you hear the word rate of flow, it means that it's movement. It's mobile. It moves from one place to another. Now, the movement of electron is the flow of electric current. So whenever the current is flowing, it means that electrons are moving from one point to another. So whenever we want to talk about current electricity, we have three important quantities we are considering. The first one is electric current. The second one is potential difference. The third one is resistance. The first one is electric current. The second one is potential difference. And the third one is electrical resistance. The first one is electric current. The second one is potential difference. And the third one is the electrical resistance. This power what? Where? L. Do you have any other L here? Okay, L is raised to power 3. We have -2, -2, -4. This is -2. So whenever you want to treat current electricity, you have three major quantities. We take them one after the other. The first one is the electric current. The second one is the potential difference. The third one is the electrical resistance. Now, electric current is defined as the rate of flow of charge around the circuit. Electric current is defined as the rate of flow of charge around a circuit. Mathematically, electric current I is Q over T, where Q represents the quantity of charge, T represents time of flow, and I represents electric current. I represents electric current. Now the unit of electric current is amperes. Now in the lab, we use an instrument called an ammeter to measure the electric current. In our lab, write it down. In the lab, that means in your physics laboratory, we use an instrument called the ammeter to measure the electric current. Now we use galvanometer to dictate the flow of current. Galvanometer dictates the flow of current, while ammeter measures exactly the quantity of current. Now the symbol for ammeter is this, while the symbol for galvanometer is this. The symbol for ammeter, you just draw a circle and write A. Inscribe A in the circle. That represents the ammeter. Galvanometer, you write a circle and put G. The G represents galvanometer. Now listen to this point. In a lab or in an experiment, the galvanometer is connected in series. The ammeter is also connected in series. In the lab or in an experiment under electricity, ammeter is connected in series. Please note this point. The ammeter is connected in series. Galvanometer is also connected in series. Now the second one is potential difference. The second is potential difference. Potential difference is defined as the work done. Work done is in taking a charge from one point to another inside the electric circuit. The total work done in taking a charge from one point to another in the electric circuit. We use a voltmeter to measure the potential difference. We use a voltmeter to measure the potential difference. And the symbol is V. The symbol is V. Now, in an experiment, the voltmeter is connected in parallel. Ammeter is connected in series. Voltmeter is connected in parallel. Now, if there is no other thing you pick today, now pick this point. The ammeter is connected in series, while the voltmeter is connected in parallel. Please. It goes a long way even in calculations. Now, Ohm's law. Now he seems super tired. In our next class, we start from Ohm's law. Now, do you have any question? Do you have any question? Sister, do you have any question? You don't talk to her. These people talk to each other. You don't talk to her. And anyway, a very big gap here. Why? Get an issue. Like for come never say man kata. Others discuss. But you don't talk to this person. Nego there and first. You crazy kid whether nego you. Like it's not facing this side. Why are you doing like that? All right.